So I'm going to put the answers up here for you to see. For that first one, you should get 3 over 2 times the square root of 3x minus 4. And so with this, what is that rule? What's the name of that rule that you have to use on this one? It's the chain rule, because you have to multiply out front by the 1/2, 3x minus 4 to the negative 1/2, and then you multiply by the derivative of the inside. Okay, so this is a chain rule, then you're just going to put it back together there at the end. Okay, number 2, also a chain rule. You take the derivative of cosine, which is sine. No, I've done this wrong. It should be negative right there, because the derivative of cosine is negative sine. And then you just have of pi times x, but then you have to multiply by the derivative of the inside, which is that pi right there. So you would end up with negative 3 pi sine of pi x. Okay. Number 3, you could use the quotient rule to do that, but it is not the most effective use of the quotient rule because you've just got a coefficient in the top there. So what I would suggest instead is you could write this as 3x squared minus 4x to the negative 1, and then you could use the chain rule on this one as well. So you have negative times 3x squared minus 4x to the negative 2 times the derivative of the inside, which is 6x minus 4. And then I just sent the negative exponents back to the bottom. And then the last one is the only one that is not a chain rule here, but I did want you to see this because you've got that root in the bottom. So if you change that to x to the negative 3/2, then you can just use your power rule to take that derivative, and you'll get your answer here. Okay, questions? Okay, chain rule is one that we kind of had trouble with whenever we were doing our derivative rules. And it's been a while. We've still been using it some as we go, but it's been a little while since we focused on it expressly. So it might be something that you might need to brush back up on. Today we're going to be doing integration by substitution, which is sort of how we undo a chain rule that has been done. So let's see. All right, so this stuff right here, if we have a chain rule, if we have the integral of f of g of x times g prime of x dx, it has to equal capital F of g of x plus c. Or another notation that you might use here, rather than doing f of g of x, we might just use, instead of using an x, we might use a u right here to show that that is some function. It's not just an x. So f of u du would equal capital F of u plus c. I'm going to let you write that down, and then we'll do a problem so you kind of know what it's talking about there. And so here is our first example that we're going to do. we have the integral of x squared plus 1 squared times 2x dx. The first thing I could tell you is that for this, you could expand all of this out. So you could do x squared plus 1 squared and then multiply it by 2x. That wouldn't actually be terrible. And then you could integrate whatever you get there. But I'm not trying to teach you how to do that necessarily. You should already know how to do that. So I just chose this as a very sort of simple example of a u du substitution. So what we've got here is this u part is the inside part of the function. And du is the derivative of whatever u is. Right? So this is your inside part of your function. Like when you're doing a chain rule, you have that inside part. And the du is the derivative of the inside. So for this problem, you can kind of see here, like we do with the chain rule, this x squared plus 1 is my u. It's my inside part of the function. So u is going to be x squared plus 1. Okay. Now, in order to take an integral, you must have your f of u, your function of u, plus you got to have your du. So what I'm going to do right here is I'm going to take the derivative of u. So I'm going to do du dx. The derivative of u with respect to x is going to equal 2x. We okay there? Alright, now notice up here, all I've got is a du. I don't have a du dx. Alright? So, if I wanted just to solve that for just du, I would just multiply both sides by that dx that's in the denominator. Right? So I would have du would equal 2x dx. Now, this is convenient because if you look right here, we've got a 2x dx. Right? So, this is how we are going to integrate these problems. We are going to use substitution. A lot of times you'll hear me call this u substitution or u du substitution. But we're going to use substitution. So, x squared plus 1, I let it equal u. So, I'm going to write the integral of u squared. So, I'm replacing that x squared plus 1 with u. And I'm also going to replace 2x dx with du. Now I have made my integral much more simple, right? I'm just integrating u squared with respect to u. And that is much easier than whatever this mess was over here, right? So, I've substituted in the u's in this case. Are there any questions so far? Alright, so I can integrate this very easily. So Wendy, if I integrate u squared, what will I get? Not derivative, but integrating. So that's where we increase the exponent by 1 and divide out front. So what would we get for that one? Good. So we'll have like a 1/3 out here. You could write u to the third over 3. That would work well too. And then anytime we integrate, what do we have to put on the end? Plus c. Okay. So we've got 1/3 u to the third plus c. Okay. So that is our integral. But we probably don't want u's in our answer because our question had x's in it, right? But we can just substitute back in because I know u is x squared plus 1. So my answer here is going to be 1/3 x squared plus 1 to the third power plus c. You can always check these very easily. I say very easily. As long as you know how to do the chain rule, you can check them pretty easily. So to check, you're just going to take the derivative. You do 3 times 1/3, which is just 1, times x squared plus 1 to the second power, times the derivative of the inside, which is 2x dx. Actually, the dx sort of comes along whenever you integrate. There, I guess you wouldn't have it. So you have the same equation that you started with. So that would tell you that this is correct. Okay, questions? Alright, let's do another problem because sometimes you need to do a few of these before you even realize what your questions are. So for example 2, we are going to integrate 5 cosine of 5x dx. Okay, so for this problem, we do know how to integrate cosine, but only cosine x, not cosine of 5x. So this is going to have to be a u to u substitution that we do here. So what is the inside for this? What is our u? It's 5x. So u is 5x. And if I take the derivative of u, du dx would equal 5. But I want this just to be a du if I'm going to integrate. So I'm going to write that as du equals 5. Come on. Quit laughing at me, Jess. It's possessed. Alright. Still not going away. Alright, there we go. Alright. Dx. So we've got du is 5 dx. So what we need is we need this equation to be in the form where we've got something with a u and then we've got the du at the end. I've got the dx here. I don't have a 5 with it, but I do have this 5 up here, right? So I could just move that 5 on over here, and it would, I'm going to write it, you don't necessarily have to, but it would be cosine of 5x times 5 dx. And so this piece right here, I can replace with a u, because u equals 5x. And this piece right here, that is my du, so I can replace it with du. And before you can integrate, you've got to have the u and also the du. You cannot integrate if the du is not there. So here we would be integrating the cosine of u du. And that makes it much more simple because you've just got a single variable. You don't have any 5s or anything complicating it. We know how to take the integral of cosine of u. What is the integral of cosine of u? It's sine of u, and we have to put a plus c on the end. And then for our last step, we'd have to plug back in our u. So we'd get sine of 5x plus c. Okay, questions? All right. Try another one. Okay, again, this one we could expand, and we could expand x squared plus 1 squared and then distribute the x. We could expand and then integrate. Some may find that even easier, but this is going to be on multiple choice section, and the answer choices are not going to be the expanded answer. So unless you want to have to factor something that's x to the 6th whenever you get this all done, then it's not the best way to do the problem, because it's not going to be what the answer choice looks like. And these are typically on multiple choice rather than free response. So for this, let's see, what do you think the u is going to be? What's that inside part? Probably x squared plus 1. And so if I take the derivative of that, it's okay if I do this time. Du would be, derivative would be 2x, and then we have the dx there. It's okay if I skip that middle step where we had the du dx and then multiplied there. So I'm going to skip that part. So we'll go straight to this. Now, we have a problem here, because this, I've got x squared plus 1 squared. I can replace this part right here with my u. That's no problem. But I could take this x over here with this dx, but what am I missing? The 2. I do not have a 2. It'd be really nice if I could just take a 2 and stick it right there. I cannot do that unless I balance it out on the outside of the integral. So what could I put out here that would cancel out the 2 that I put on the inside? 1/2. So I can do this. I can multiply by a 2 on the inside as long as I put a 1/2 on the outside. Because I could, that 1/2 I could move it back in, multiply it by 2, you get 1, it's gone. Okay. So I'm going to have to do this so that I have the du here. So I'm going to have 1/2 integral of, I'm going to take all this stuff and put it together. I'm going to write it like this. I'm going to write x squared plus 1 squared, and then you would have 2x dx. Okay, so if you do this, then you can take that x squared plus 1, and you can replace it with a u. You can take that 2x dx, and you can replace it with a du. Because u equals x squared plus 1, and du equals 2x dx. And so that means that our integral looks like this, 1/2 integral of u squared du. So to integrate that, I'm just going to leave the 1/2 out front for right now. This is just a coefficient. Justice, what would I get whenever I integrate that u squared? Just integrate the u squared. Good. Yes, very good. Right, and then we would also put a plus c out here on the end. We just always put a plus c when we do a general integral. Okay, very good. Anytime you integrate, like for example, if you were integrating 2x dx, right? If we were integrating that we'd just use a power rule for it, right? We do x squared, and then we do 2 divided by 2 out front, and we put a plus c, right? So we've been doing that all along. It's just more evident that you're doing that here. This is not mathematically correct. It's not actually mathematically correct to say this, but it works. It's almost like you're replacing your du with a plus c. Okay, mathematically that's not what's happening exactly, because this right here just tells you the variable with which you're integrating with respect to. So it's not technically what's happening, but if you just think of it as that du gets replaced with the plus c, then you'll be in pretty good shape for doing all of these problems. That's a good question. All right, so for our answer here, the 1/2 and the 1/3, I could multiply them together and I'll get 1/6. And I could go ahead and replace my u with our x squared plus 1 to the 3rd power, and we've got our plus c. Okay, questions? That one was a little bit tougher because you didn't have what you needed for the du, so you had to adjust a little bit there. Now, I do need to tell you, you can only adjust by putting coefficients in there. So if we had gotten to that and we needed x squared and we only had an x, we could not multiply by x on the inside and outside. That would not work. Okay, here's our next one. Okay, so we're integrating 1 over 3x minus 5 squared with respect to x. Now the last few that we did, you could do by expanding out and then just using the power rule, but this one you cannot do that with, because if you could expand out 3x minus 5 squared, but then it's in the denominator, and you can't just use the power rule whenever things are in the denominator. So this one, you absolutely have to use substitution for this one. So, Liliana, what do you think the u is for this one? The inside part. Very good. 3x minus 5. So then, if 3x minus 5 is my u, what is the du going to be, Liliana? Just 3, and we'll put a dx with it. So, we're wanting to substitute this part right here, the 3x minus 5. We could put a u right there because 3x minus 5 equals u. But the du has to be 3 dx. I don't have a 3. So I am just going to add a 3. It makes my life easier. But to do that, I have to put a 1/3 out front. And so this 3 dx, that can be replaced with du. Okay. So right now what I've got 1/3 integral of 1 over u squared du. And I don't really know how to integrate when I got things in the denominator, so I'm going to write it like this. 1/3 integral of u to the negative 2 du. So, if we integrate that, u to the negative 2, what are we going to get when we integrate? Very good. Not negative 1/2. Because out front, there's a 1 out front, we're going to divide by just the exponent that is up there, not the original, but the new one. So we just get a 1 over negative 1 for that. And then we'll put a plus c on the end. So you just end up with negative 1/3 u to the negative 1 plus c. Or we could write that as negative 1 over 3u if we move the u back down to the bottom. Plus c. And then we still have a u here, so we want to replace that with our x. So we'll have negative 1 over 3 times 3x minus 5 plus c. Okay, questions? Okay. Some of the ones you're going to see are going to look like this. They're going to ask you to solve the differential equation, and it's going to give you dy over dx equals something else over here. So these are really the same type of problems. They just look a little bit different in the way that they ask them, and your textbook does this, so I want to do this here. To solve this differential equation, you would need to multiply both sides by dx, which would cancel your dx over here on the left side, and then you would integrate both sides. And so if you are integrating dy, you just get y, and over here you have the integral of x plus 2x squared over the square root of x dx. Now, what would your u be for this one? Okay, let's try. If you have the square root of x, that's like x to the 1/2, right? And so du would have to be 1/2 x to the negative 1/2, which would be like 1 over 2 square root of x. So I could replace this with u, but does that help me any with the stuff that's on the top? Oh no, terrible, right? So that doesn't really look like it's going to work. Our other option is maybe this top part, the x plus 2x squared. Maybe that's your u. But if we take the derivative of that, we're going to get 1 plus 4x dx. Is that going to help us any with the square root in the bottom? No. So if you run into this, what you probably need to do is you got to reset, because this is not a u du problem. And I gave this one to you specifically because they do this to you in your textbook, and there's going to be a couple you have tonight for homework that are not actually u du problems. They're kind of mixed in with the others. So what could we do for this one? Okay. This is what we're going to do. We're going to do x plus 2x squared over, I'm going to write this as x to the 1/2 dx, and then I'm going to do the love connection for this one. And especially for your homework tonight, you're probably going to be in u substitution mode, because that's what most of the problems are going to be. If you run into one of these, though, and you can't get u du to work, then you might need to try something else. It might not be u du. So if you do this, you are going to get, right here, when you do x over x to the 1/2, you're subtracting those exponents. 1 minus 1/2 gives you x to the 1/2 power. And then you'll have 2 x squared over 1/2 is going to give you x to the 3/2 power. And so this one you're just going to use that regular power rule for it once you get that set up. So x to the 3/2 here, and then out front you got to do 1, and it's going to be divided by that 3/2. And then for the second one, you're going to have x to the 5/2, and out front you got a 2, it's going to be divided by 5/2. I'm going to put a plus c on the end. And we don't like to leave those complex fractions, so dividing fractions is easy as pie. Flip the second and multiply. Right here you're going to get 1 times 2 over 3, so you get 2/3 x to the 3/2. And then over here you're going to have, let's see, 2 times 2 over 5, so you'll get 4/5 x to the 5/2 plus c. So you might run into a few that are not substitution, so watch out for those. Okay, so that covers pretty much what we're going to do tonight. 5 through 23 odd is going to be your assignment. And let me just double check and make sure that that's right, that everything is something we can do. Oh, let's see. There's a couple I do need to take out, sorry. Now that I look back over them. Let's go to 21 instead of 23. And, oh, you can do 15, but 15 looks like you can't do it. It's a bad problem, because it looks like this, 5x. Okay, it looks like this. What do you guys read that as? 5x to the third times square root of 1 minus x squared. Alright, that's also the way that I read it. That's going to be a major problem because u would have to be 1 minus x squared. Du would be negative 2x dx. But you got x to the third out here. So, I did look over this and I thought to myself, no, we can't do that one. But I realized when I looked at the answers, that's not what this is asking. This is the integral of 5x times the cube root of 1 minus x squared dx. And if I look at the answer, I can tell that that's what they were actually doing. But it's not a good problem because there's really no way of knowing that that is 5x to the third, 5x, not 5x third, and is the cube root. But on that one, this is what this means. So you would also, like, you probably want to think of this as, let me just show you something. Let's just do 15. It's about time to go anyway. You won't get started on your homework if I let you. So let's do 15 right now anyway. So u, in this case, would need to be 1 minus x squared. And so du would be negative 2x dx. Now, this time I've got the dx right here that I need. I've got the x that I need. I've got this 5. But I need that 5 to be a negative 2. Right? This is what I usually think of. I usually just think of taking that 5 outside. 5, I'm putting you out here. You're not here anymore. And now I need to add a 2. Right? And if I add a 2 right here, actually I need to add a negative 2. And if I add a negative 2 right here, where that 5 was, then I've got to multiply by a negative 1/2 out front. Or you could think of multiplying by negative 2/5 on the inside and negative 5/2 on the outside. But for me, it's a little bit easier just to kind of move that 5 out and get it out of the way. Then you're going to add in that negative 2 that you need. So if you do that, then you've got that 5 times the negative 1/2 would be negative 5/2 integral of the cube root of 1 minus x squared. And we'll put this negative 2x dx over here. So this part right here is u, and this part right here is du. So you would have negative 5/2 integral of the cube root of u du. And I'm going to write it like this so I don't get confused. Negative 5/2, that is u to the 1/3 du. Okay, questions so far? And then you just use the power rule. So you would have u to the 4/3. And since this is the only term, I'm just going to put my negative 5/2 out here. And I have to divide out front by 4/3. So that's negative 5/2 times 3/4, which is going to give me negative 15/8. So, and plus c. So I get negative 15/8 u to the 4/3 plus c. And that's going to be negative 15/8 times, I forgot what the u was now. What was it? 1 minus x squared. So 1 minus x squared to the 4/3 plus c. And let me make sure that's what they leave the answer as here. Yeah, they leave it like that. And I'd say that's probably about the hardest you'll get tonight. Harder is coming, just not yet. Just if that makes sense today. Okay, overall, okay. I just want to make sure, because since you learned how to just do integration period 30 minutes ago, yeah, so, okay, in the morning, I will not be up here. I will be downstairs outside the meeting center. So I can still help you, but I just won't be, I've got to be on duty to keep the freshmen from acting up out there. So, but you can come down there and I'll help you on those. And if you, we'll try to just kind of do a little bit as we go. Hopefully, today I caught you up on that first stuff, so if this made sense, if we can just keep you where what we're doing makes sense, even if you might have some gaps, I think you'll be alright. I want you to do this homework. Now, if you were to get the homework done, so do the homework. if you were to get the homework done and are just bored and have more time, then the one that says